Oh yeah. Make sure you put your headphones back on the chair when you guys don't walk out.
Don't walk away with us. They electrocute you.
Right, we're driving. Alright, we're going to go ahead and get started. Thank you guys for coming. And thanks to our sponsors. This is Julie Deegan. He's responsible for operational security of Firefox backend infrastructure at Mozilla. He is the author of Securing DevOps, published at Manning Edge, and a developer of various defense security tools. Julie can be found on Twitter and GitHub at JBEHENT. And this is his talk, a DevSecOps approach to brain security.
All right, hi everyone. Like I said before, I will speak up, so you don't have to use the headphones, but if you prefer, you can. But if it's too loud, tell me, or that is guy over here. So, this is going to be, to me, this is one of the most difficult talks I've had to write. I've given a lot of talks on technical topics, and it's usually pretty easy. Find a problem, write a bunch of code, show the solution, everybody applauds, that's great. This is different. This is about figuring out both cultural and technical ways to better secure our organization and better secure Mozilla. So, who am I? I have a clicker that should work sometimes, except when it doesn't. Okay, so we'll do it this way, that's fine. I'm a security engineer. I run a team of security engineers at Mozilla that's called the Firefox Operations Security Team. And our job is to secure the backend infrastructure of Firefox. So you may have heard of Firefox. It's a browser. It's very popular. Some people use it. It has a fairly large backend infrastructure. We have like dozens of cloud services to do things like updating, updating versions on our user machines, or sharing your personal data and your browsing data throughout multiple machines, managing your accounts, installing add-ons, and even some more user-facing stuff like allowing you to share files securely, etc., etc. So all that stuff needs to be somewhere, and it's usually in the cloud, either AWS or GCP or Azure, with all of them, and it's a pretty large infrastructure footprint that we need to secure. So that's what I do. The book Securing DevOps was written a few years ago as I was kind of figuring out our AWS security strategy, cloud security strategy, and web application security strategy, and put a lot of the ideas and feedback of implementing these techniques into this book. So a lot of what I'm talking about today on the technical side is documented in Securing DevOps. But what I realized is that the technical aspects are really just one part of making all of this succeed. And what's missing in the book, and what I'd like to talk about now, is the glue, the cultural glue that matters in building security into organizations. So really fundamentally, and I realize it's lunchtime and you're probably all starving, so philosophy isn't really the right time for this, but why are we here is a question I really want to ask. There are days I wonder, why the heck are we here? As computer scientists, we are here to do what exactly? To prevent our fellow engineers from shooting themselves in the foot over and over and over again? That doesn't make any sense. No other industry has people like us. You don't have security plumbers. You don't prevent a plumber from burning their hands every time they try to weld a pipe or something like this. It doesn't exist in any part of the industry. Sure, we have regulations and we have building codes and these sort of things, but not like in computer science. It's a very different way of doing things. We have this culture of security teams need to grow and they need to be everywhere, they need to be present in every part of the organization because otherwise everything's going to blow up tomorrow. And to me, that just doesn't sound right. Are we useful? I mean, we have pretty large security teams in many organizations now. Do they do anything useful? I don't know. I'm looking at this graph, look pretty. I don't know if it means anything, but it's from the Verizon DDIR report they publish every year, and they actually put a bunch of, they have a lot of fancy graphs that mean nothing. And a lot of them are not very useful, but this one tells me, well, what's interesting is that this is a percentage on the y-axis, so there's actually no notion of volume, whether it's increasing or decreasing. But apparently we're like going up and down on organized crime. And I guess the guys just make a bunch of money, and then they all go to Sarasota on vacation, and they make a bunch of money. But I mean, they seem to be according to this graph, so we're not super useful. Ransomware damage cost predicted to hit 11.5 billion by 2019, so I'm not worried about their retirement. They seem to be doing fine too. So apparently we're not super useful. Are we worth it? We're pretty expensive. Apparently, typical organizations spend between 0.2 and 0.9 of company revenue on cybersecurity. That's nuts. That's a lot of money. If you're in an IT department, apparently like up to 10% of the IT budget is focused on cybersecurity. That sounds like a lot of money to me for people who are just here to prevent their peers from shooting themselves in the foot. In 2019, what we're spending on information security product and services is estimated to reach over 124 billion. If you're a venture capitalist or if you're a startup founder, you're doing great on security right now, right? But I don't get the sense that we have better security for all the things that we're doing. And surely there is something that we're missing here. Are we helpful? Do our organizations think that we provide value? This is how a typical software development lifecycle works. Developers and business folks and product owners, etc., we're all getting to a room like, we have a major business need. We need to build software for it. They're super smart people that come up with a perfect design, and then they will go and implement it. They will have this prototype, it works great. They have to test, they do all the testing, everything was great. They're like, all right, we're ready to go, let's deploy. And that's when security comes in and say, what the fuck is this? Who is trying to deploy something without talking to me first? And I'm guessing you're familiar with that situation. You've all been in those meetings, right? So security freaks out like, what do you think you are? You can't deploy shit without me looking at it first. So security is like, all right, I need 2 weeks to realize it. But we're supposed to launch today. Nah. 2 weeks minimum. All right, 1 week, maybe, but not sure. So security starts reviewing the project. And once we start looking at the project, we realize it's a freaking REST API with a database. We have 100 of those already running. There's nothing new. They use the same framework they used for the past 3 years. It's really not that bad, right? It's not doing anything fancy. All right, fine, this is good. You guys can go, but don't do it again. Right? Don't do it again. And so the application ends up going to deployment only 2 weeks later, right? And we had this culture internally, and the one that I really hate. By the way, this exists in my organization too, and I'm fighting it, but it's there. This culture of talk to security. And I hear engineers say it all the time, and it bugs me. Right? If you want to add a rule to the firewall, talk to security, right? Can I use this hash algorithm? Developers will be like, I think we need SHA-256 for this. Well, I don't know. Have you talked to security? Why do you need to talk to security to use the industry standard that's used everywhere on the planet? Yes, of course you can use SHA-256. We're adding a new page to the website, and this one is a pet peeve of mine. You're changing something in a major, mature production application, and you need to talk to security to add a rule to a web application firewall for that page. Why? No. Security teams are not operational teams, but a lot of organizations work this way. And then you have the like, here's a new developer, they're new to this, they'd like to do work, can they talk to security first? Okay, I guess I can train young developers too, but that really doesn't seem to be my responsibility. And the main problem I have with this is that this culture, what it forces really on the organization is that it consolidates security decisions into the hands of security people. And what that does is, first it slows down everything, because we're a bottleneck, and it just doesn't scale, it doesn't scale, then we end up going up to management saying, we can't do security, we need more people, more resources, spend more money. That 10% of the IT budget would be great, it could be 15%. And the second one, and the one that I think is really insidious, and I'm really, really worried about, is that it absolves developers and operators from caring about security. Imagine a builder who's telling you, I don't care if the wall is straight, there's a security team over there, they're going to check it for me. That doesn't make any sense. It is not our job to make sure that the code that is being written by developers and operators is properly written. It is our job to define how that code should be written in the first place. And then it is their job to do it and to follow those recommendations and those building codes. But when we have this culture, we completely absolve them from thinking about security and owning security. And a lot of organizations are in this situation today. And they're failing. They're spending a lot of money on cybersecurity. They're not getting any results. They come up with excuses as to why things are not working. It's somebody else's fault. It costs more and more and more and more and more to do the things we were doing 10 years ago. And we're adding more and more layers of security products and techniques and people, and it's still not providing more value. So, a few months ago, I was reviewing the security investments in my team. And I was talking to my management about where we're spending most of our time. And my boss asked, you seem to be very underinvested in infrastructure security. Is that normal? Is that good? Is that bad? What does that mean? And I had to scratch my head for a second here and think about it. And like, well, it's true. We don't spend a whole lot of time in infrastructure security right now. I pulled up some of our security metrics and I started looking at how we were doing. All of our AWS security tests and GCP security tests and web application security tests, etc. And looking at how are things trending, where are the issues, etc., etc. Before I could answer that, yeah, I think our investments make sense. Overall, infrastructure security is doing well. We have matured our AWS environments to the point where every new service gets rolled out into a secure by default environment. We have defined our web application security requirements to the point where the developers know what they need to add to their app when they build it. We're doing well. We think we can de-invest in infrastructure security because at this point, the operations and the developer are the ones, the gatekeepers essentially. They're the ones in charge of keeping it this way. We still run the test and we will detect a regression if it happens. But I'm not going to go tell an ops how to open a file. They know how to do it, in fact. They help define those rules in the first place. They help write some of these tests and decide how things should be built to be both secure and maintainable in the first place. So we let them run this in there. And when they need us, they tell us. This is vastly different from our investment from a few years ago. When I joined this cloud services group at Mozilla around 2015, we were massively invested in infrastructure security. Most of the time was spent in infrastructure security because we had this new world of we're going to ramp up the way we do deployments in AWS, and we need to figure out what that means. What are the right rules? What's the right way to shape a VPC? What's the right way to shape a firewall? How do we connect two accounts together? What's an IAM? What's an access control for an S3 bucket, etc., etc. Most of our time was spent on infrastructure security. But you're supposed to do this thing only once and then move on. But I see a lot of teams that never move away from that. They stay in infrastructure security, they keep maintaining their infrastructure forever, and that's what they do. They're the infrastructure security team. I don't want to maintain firewalls for the rest of my life. I don't know about you, but I like doing other things too. It's not the funniest part of the job. So, of course, we didn't get to the point where we didn't need to do infrastructure security so much from day one. There was a process here. There was a road from the moment I joined the group and today. And what I want to talk about is how we got to that. And I'm going to share a bunch of the tools, all of which are open source, that you can use in your organization. Probably not exactly the way we do, because every organization is different. But at least you can inspire your own security strategy from these tools and maybe force them, modify them, and use them for your own stuff. So back in 2015, I was a security engineer in an InfoSec team, traditional InfoSec team who were yelling at people when they couldn't open a VPN properly from afar, weren't directly embedded with the operations team, etc., etc. And one of the operations managers said, look, I'm going to do this cloud thing, and I'm going to do the security of it too. And I don't want to do it with an InfoSec team that doesn't understand what we're talking about. So I'm going to look for a security engineer to join the team and help out and figure out with us how we do security in AWS. Do you want to be that security engineer? Like, well, that sounds scary. Like, I have a comfy team here, there's a bunch of us, we're buddies, right? You want me to join a bunch of people I don't know to use this DevSecOps thing? And that's a Google trend of DevSecOps in 2015. My comfort zone is here, like, yes, I want to join this thing. Like, we're pretty, it's fine. This is where we were. Like, I don't know, maybe it's a scam. Maybe it's a terrible idea. Maybe I should just keep doing what I'm doing. But I decided to try it out, and this is pretty much how I felt walking in. Those are the rest of the operations team, and I'm the security engineer. And my typical model for approaching an operations team is like, I know the truth, and I will tell you what to do next. Lions have long keys, and so do operations folks. So I couldn't apply that model with them. And thankfully, I knew them enough that I knew that trying to play the almighty security engineer would not work well for me. So I took a step back and I'm like, all right, I got to figure out how to work with that team. Because it was a very different structure for me. I used to be part of a security team, and here I was a member of an operations team. Right? So I know enough of operations, and I've been a sysadmin, and I know how to do that stuff well enough that it was completely foreign to me. But still, the culture is different. Right? The culture is different. It's not about waking up in the middle of the night for security incidents, but waking up in the middle of the night because the database is down. They're more focused on availability than they are on access controls, right? So you got to figure out which language you speak and show that you can communicate at the same level. So I realized what I needed and is a project I could contribute to the team to show them that I was on their side and I wanted to be useful and I wanted to contribute and help. And thankfully, this project was pretty much handed over to me on a platter. One of my good friends, Cody, shortly before I joined the team, actually in 2015, fucked up. And he did so with the absolute mastery of a very senior engineer who has run commands millions and millions of times, and once those commands go sideways, he pushed the repository that contained all of the clear text secrets and credentials of the infrastructure to GitHub. That's pretty much how everybody ends up. That must hurt. Now, we got lucky. This was a private repo, but still not a very comfortable situation to be in. So we're like, all right, we got to figure out secrets management. Obviously, the current system doesn't work. So I was, well, I'm a security engineer. I guess I can do this and help out. So why don't we work on this together? And this was very different from my usual approach to solving problems. As a security engineer, the way I normally solve problems is somebody tells me they have a problem, I go in my corner, I come up with a state-of-the-art of the perfect world of everything, I build a tool, and then I give it back to you and say, use this. Like, I can't, it doesn't fit, like your thing is round and this is square, like I don't care, just make it fit. But here, it wouldn't have worked. I needed to make sure that whatever I was building would fit exactly into their workflow. And so I sat down with a few of the engineers, and we came up with this notion of like, all right, we need to figure out how we are going to do secrets deployments in the AWS world of auto-scaling groups where systems aren't managed by people but created automatically, etc., etc. This is 2015. Like nowadays, these solutions exist. It's known as a bootstrapping of trust. You can use Kubernetes secrets. You can use AWS SSM, Vault, whatnot. There's a bunch of stuff. The subtitle here, SOPs, or what happens when security guys write ops tool, is what the ops team is. It's not as terrible as the title makes it sound. They actually really like it, but there's still a little bit of the snark between security and ops. So what we did here is we essentially started with, all right, this is what we could do today that's fairly easy. We can use something like Blackbox, we use GPG, we push our secrets to the code commit. Jenkins will move that to S3, these two instances can download this. quickly we realized that doesn't really work because we need to move the GPG keys, and that's a pain in the ass. So what about we use an AWS KMS to do the encryption, and the EC2 instances have a role, and they can decrypt the files as they bootstrap. And we implemented that a little bit further. What if we had S3 versioning in there? Does it work, etc., etc. Fourth iteration of this was a full-blown YAML editor that uses encrypted, essentially will encrypt YAML files, but keep the structure of the document so you can have meaningful diffs, and that will be pushed to S3 buckets and retrieve them. It was getting pretty fancy. But the cool thing about this process was that by the time I got to proposal number 4, the operations team had shaped the design heavily to what they wanted. And I had kept the security requirements to what I initially wanted to provide from a security perspective. Now, they really wanted this. Like, yes, this is great. That's exactly what we need. Go build it. I only had one problem. This was just a drawing on a whiteboard. I didn't know if I could do this. But I mean, I assume, well, okay, I think it's going to be fine, and maybe we can do it. And within a few weeks, with the help of a few better developers than me, we had a Python prototype that worked. It worked well enough to start using it. And over time, it got rebuilt in Go. SOPS is a pretty popular project now. You can check it on GitHub. I'm not sure people use it. We still use it internally. What's interesting to me, besides the tool itself, is that I didn't just build a security tool, I built an operational tool that did things security. And that reversal of mindset is very, very important. It's not about the security tool, it's about getting the job done and putting security inside of it. And that was very successful. We reproduced that model on a bunch of other initiatives afterward because it allowed us to have buy-in from the engineering team and the operations teams from day one. And it also defined the model by which we operate for the time being, which is instead of having teams that were disconnected, security and operations security was essentially embedded in operations. You carry the weight. You're part of the same meeting. If there is an incident or an operational incident, you're with the team. If it's in the middle of the night or the weekend, you're with the team. And over time, security becomes part of operations. Operations owns security. It creates a cohesive group of people who can work together and solve problems together. At the time, I was directly in the same team as the operations folks. And as we grew, there are 8 people doing security under me now, so it's too big to be just one team. So we separated into groups, but we still report to the same manager above us. And this model is very different from what you typically see in organizations, where in organization you generally see a centralized security organization. And that's typically a chief security with a few security teams underneath it. And that is a separate organization entirely from the engineering groups. What we have at Mozilla is a distributed security organization, where we have strategic security folks that are all the way at the top, able to talk to the C-suite. But the security teams don't report to the CISO. We actually don't even have a CISO. We have a senior director of trust. The security teams, in fact, are directly embedded into the engineering department. I report to a division of Firefox that is in charge of infrastructure engineering. We are part of the engineering organization. The main difference between the two, and that's very important, is that in the centralized model, security is a separate cost center, whereas in the distributed model, security is part of the product organization cost center. Security is part of the product cost, where here, it's not part of the product cost, it's separate. And when you're at the board level and the director level, identifying security as a separate cost center changes the approach to security completely. Because in that option, you can cut that cost center if you want to. Here, you can't. It's part of doing things. It changes everything in the organization. It also allows security people to have better interactions with the developer and operations. Now there's a model.
How do you handle compliance in the distributed model?
In the distributed model, it's the same way. It's not different. Security is still doing the same job here. They still get their compliance directives from the CISO or the legal department. They still have to do the same work they're doing. It doesn't necessarily mean, it's not because you're in a CISO organization and you get your orders from a CISO that your requirements are any different, particularly if those requirements come from outside the organization. In fact, compliance and the majority of the compliance work isn't security work. Operations team have to do a lot of the compliance work. Developers have to do a lot of the compliance work. The fact that it belongs to security is just because we need to give something to the CISO to do. A model that I like, if you are in a CISO type organization, and most organizations are in this model and they can't really move away from it, is to try to implement embedding in your organization, which effectively means you take your security engineers and you give them to other teams. And embedding here has a strong meaning. It's not just that you get your security people to go spy on the other engineering teams here. It means if you have an engineer, a security engineer that goes into a dev team, the manager of that dev team can tell the security engineer, I want you to work on X next week because we need, for example, we're moving to a new work framework, we're going to deploy in 3 weeks. I want to know that it's secure and it needs to be done now. And that engineer may go back to the security manager and say, hey, I need to shift my priorities because I need to work on something. Is that okay? And yes, it's okay or it's not okay, etc., etc. But here, essentially, the engineering managers have a say in what the security folks work on, and they can direct them to the most important things to them. That's a better communication channel. It also allows the security engineers to get information directly from where things happen, rather than having to go through the entire disconnect between organizations. So you don't have to essentially try to figure out through many high-level automated testing tools what the state of your applications are. You can just go as it is. Now, that's not a one-way process. You can have a reverse process where the developers are allowed to participate and contribute to the security organization. We call this security champions. An easy way to do this is, if you're running a security training, the people who subscribe and come to that security training, they're your champions. They have an interest in security. They want to hear from the security team, they want to maybe progress and use that to progress in their career. And it's very easy to create a security champion organization. You just take the people who are interested in hearing from you. But the way you do this still matters. You can't run a security closed-door security organization and have security champions. You need to open your doors to them. You need to share everything to them. You need to share your security tests. You need to share your incident reports. You need to share your lesson learned to them. And why keep them for yourself anyway? Because it's useful to these guys, not you. But these models work. And effectively what they allow you to do, they allow you to avoid having to make assumptions based on bad data. And one thing I learned, I'm not sure an anecdote, is that assumptions lead to vulnerability. When you operate on incomplete information, you open vulnerability in the organization. The main goal of a security team is to get rid of all assumptions. And there are many ways to do this. Some of them are technical, some of them are cultural. But frankly, before you go spend 3 years in an EDR project to get visibility into every single endpoint, why don't you just talk to freaking people first? That seems a lot easier and a lot less expensive than spending $2 million on Splunk or whatever. I don't know. Maybe you can have a drink too, it might be fun. And I'm serious, like a lot of these issues come from the fact that as security engineers, we don't want to talk to people, or we don't think we can talk to people. We don't think we can get closer to the rest of the organization. I think that's wrong. I think we can create relationships that are a lot stronger than what tools would give us, essentially. Now, the anecdote I'd like to share is that if you're Firefox users, you may have noticed sometime last year in May that we had a little issue with our extensions. And in fact, every single Firefox on the planet blew up at the same time, at a very specific timestamp, on May the 4th at midnight, because the signatures for add-ons broke. Now, the person standing in front of you today is the person responsible for those certificates. And I was on parental leave. I was in a trailer in Arizona when my boss called me and said, all add-ons are broken, get to a computer. I'm like, what do you mean now that OpenHack can use it? Oh shit. Now what's interesting about this, the technical issue were extensively documented on our blog, but what really happened is that when I took over the management of the PKI that signs add-ons, I collected information about how the signing process works. And what I either was told or understood, it doesn't matter, is that add-on certificate expiration is ignored by Firefox. And so I just created certificates that were valid for 2 years, and when we came to the rotation, we're about to roll out to a new certificate, but production things came up and we didn't do it in time. And we're like, well, it doesn't matter because Firefox ignores expirations of certificates anyway, so it's going to be fine. I made the assumption it was going to be fine, I didn't check it. In fact, the real rule was that Firefox ignores expiration of the end entity certificate, but the intermediate or the root certs, it very much does check the expiration. So when the intermediate expired, everything blew up. Don't make assumptions. Go test this thing. Don't make assumptions. Yeah, there are plenty of examples. If you read, there's a fantastic New York Times article on what went wrong with the Boeing 737. And at the root of it is really people making assumptions on which systems were enabled and which ones weren't. And the verification chain broke because of assumptions. And it had dramatic consequences on things. And this is something we really need. Every time you hear assumption or I assume in a conversation, make a mark, that's a flag, go verify this thing. Because it's probably not true. So the most important thing as security organizations is we need to be able to trust our data. We need to have data that is meaningful. And I'm not talking about, hey, we're under heavy attack, we're getting 1 million Nmap port scan a day. That's not data that's leveraged. You can't do anything with this. I'm talking about data that really means whether you're improving or your security is getting worse over time. And that data is specific to your organization. For us, some of the things we care about is we have a battery of AWS security tests, and overall it's trending upward. There's a little bit of a delta here that I'm concerned about, and I dig into regularly, but not worried enough that it's a concern. We have, in Heroku, we had an account management problem, and when we started working on this, we had essentially like 38% of the Heroku account that were out of our own internal security compliance. And over time, we fixed all of those in our training to make sure it's okay, et cetera, et cetera. Those metrics are specific to my organization, and I can look at them and understand what they mean. I can tell a story around them, and when they change, it tells me that something's happening, and I go dig into that. I don't make assumptions that things are fine. Now, you need to be able to trust your tests. And those tests, no matter what security vendors are going to tell you, cannot be generic. They can't. Security tests that are meaningful belong to your organization only. I can't give you mine. I mean, sure, you can go check them out. That's github.com, Mozilla Frost. It's a PyTest, unique testing framework for AWS and GCP and Heroku, etc. It has a bunch of tests that matter to us. And you can probably fork it and modify it and make it useful to you. But if you run those tests right now, maybe some of them will be useful. Right? The test around making sure all of your administrators have multi-factor auths, that's probably useful for everybody. But this test here isn't useful to you because this one checks the running EC2 instances and goes look for the base image, the AMIs, and make sure the AMIs are either owned by us, actually not either, are both owned by us and were created in the last 90 days. That's how we check that our running systems are within reasonable level of patch updates. And that's a test that's specific to us because of the way we do things, because we do immutable systems, because we do deployments in a certain way, etc. This test tells us and helps us find servers and systems that are getting out of date, right? And we trust that test, and I'll tell you why. Because I didn't write it. The operations team did. We had a first version of this test that was terrible. We were returning, I went to the operations manager telling him, everything's out of date, it's terrible, what's going on? And we looked at the test and realized it wasn't catching the right thing. The policy we had put in place wasn't correct. And so we worked with the operations team and they told us what they considered to be an up-to-date instance. And we essentially coded that into a unit test that we run every day. You need to be able to trust your test. I remember, I think it wasn't too long ago, there was a mess between the US and Iran that I think it's the governor of Texas or someone doing cybersecurity there who said, we're seeing large waves of cyber attacks coming from Iran. And the journalist dug in and was like, what do you mean? Well, yeah, of course it was port scans. Like, okay, like, you may be seeing cyber attacks coming from Iran, but that's probably not a bunch of port scans coming from IPs in Iran. Like, first of all, if you're a nation state, you don't run Nmap on your government against your guy going in, like, putting his code on a hanger, seeing it at his desk, like, turning on Windows. Like, all right, am I connected to the, shit, I can't open the page because of the proxy, and that's fine. I'm just going to run Nmap from here, from his government building in Tehran. Like, no, those tests are terrible, that data is terrible. What that tells me when I hear this, that you have no idea how secure you are. You have no idea. You're using metric that doesn't make any sense. And I never want to be in a situation where an executive comes to me and says, what is the state of your security? And I don't trust my test or my data. That's terrible. It makes us look like amateurs to the rest of the organization and to our operations team. Whereas now, when I go to the operations manager and I tell them, look, I think we need to invest in fixing out-of-date instances, I can have a real conversation because the data is trustworthy. We define the test together. And that's very important. The other part that's extremely important is setting the expectations. A lot of organizations, if we go back to my old joke SDLC diagram from the beginning, is that you get to the point of deploying and security freaks out. And then security says a bunch of stuff that nobody knew about. Like, of course you have to implement a content security policy. Oh, really, we do? And the problem a lot of organizations have, and what we used to have, is that we weren't setting the expectations early on. We were telling people when they're ready to deploy that they need to do X, Y, and Z. And like, well, I already wrote like 5,000 lines of code on this thing, I'm not going to rewrite it. So it's too late. We're not doing security at this stage. So you need to set the expectations very early on. We tried a few things. I mentioned, as people were sitting down, that I worked with Simon Bennett, the lead dev of Zap. And we used that to implement something we call the baseline for web security, where essentially we have a set of core security headers and core web security rules that we want to have implemented everywhere before we want something running in production. And that runs through Zap, and Zap implements those rules. The idea was that we could essentially tell developers in their CI environment, to run so that's their application running, right? The package is in Docker, and it's a simple web app. And they would run the Zap container against their application. It would tell them right away, as they are going through pull requests and whatnot, what headers they're missing and what needs to be implemented before they either merge that pull request or deploy it to production, etc. Here it's missing some content security policy and its content type option. It's telling them right away in the output of the continuous integration test. This didn't work. and I was very hopeful that it would. I actually have a whole section in the book about, like, this is great. It didn't work because I think it was a mix of we were too deep in the continuous integration of web applications that we really don't usually mess with. It was hard for us to get the devs to like run their app exactly like this and code our container exactly like this, and then it would take another 5 minutes to run. It was a pain in the ass every time we had a pull request. And also, I think this output wasn't super clear, which was that they didn't quite know what to do with it. They didn't quite know how to make it actionable. But we got something else out of this that is extremely successful. That is our web security checklist. And it's more than just web. It's actually, anytime you want to create a new cloud service, come to us, we give you the checklist, and you have to go through that checklist. You can see it, github.com, Mozilla Services, websec-check. It's pretty long. There's a bunch of stuff that's specific to what we do internally, but a lot of it is also industry standard. And what's interesting about this is that I mentioned that we really improved infrastructure security over the last few years to the point where we're not really investing a lot in it now. And in fact, this entire section about infrastructure security, if an application gets run on the core infrastructure, what we call the paved road, it doesn't need to do any of this. All of this is handled by default. So that's a really strong incentive for developers to not go do their own shadow IT. They get a bunch of stuff, including a bunch of security stuff for free. And the checklist tells them from the get-go, even before they write too much code, here are all the things you need to do. Now it's a bit heavy. The first time they look at it, they're like, I'm going to have to spend 2 days going through this entire thing. But after they've seen it like once or twice, it's quicker. They realize it's not that much work. Adding a header, making sure you have logs in the right format, etc. So it's not that bad. The other thing that really worked is giving developers self-assessment tools. And that's observatory.mozilla.org. You can plug in your site on there and it gives you an upgrade and it tells you what you're missing and it tells you how to fix it. And what is fantastic about this is when you pair it with the security checklist, we're essentially telling developers, go implement those controls, right? And then check that you have them correctly implemented through the observatory. And guess what? They don't need to talk to us. They love this. They don't want to talk to us. They want to do their own thing. They don't want security in 2 seconds every time they do something security related. And what we found is that developers were pretty good at adopting and getting to an A+ grade on their site. But even better than that, project managers would add it to their readiness checklist that the site had to get an A+ before going to prod. And so I would be sitting in those meetings about, is this service ready for public release, etc., with all of the directors signing off on it. And one of the items was, yes, all the security stuff is done, we're getting an A+ on the observatory. And I'm like, woohoo! And I wasn't even, nobody asked me a question, they just took the checklist and did the thing and came back and it was done. Like, okay, that's fine. So this really worked. So the lesson here is, clear expectations, well documented, checklists that are actionable, don't take, I love a lot of the existing, whether it's OWASP checklist or CIS, etc., but you need to rewrite them for your organization. Don't give a 50-page PDF document to your devs, just telling them to go fuck themselves. It's true, like nobody wants to receive that PDF document. Rewrite it to your, even if you have multiple teams using multiple frameworks, just rewrite it, I'm sorry, just write it for your organization so it's actionable and it goes quickly towards it. And then give them self-assessments too. Is how you get to have developers care about these things and follow the building codes and profit. The last thing I want to mention, I'm on time, fantastic, is not having to say no. And a lot of security teams are the no team. It's changing, we see it changing, we see a lot of people talking about doing this differently. But it's still the case in a lot of situations. I say no sometimes, but it's not that often. And here's what I think is happening. My interpretation may be wrong here, but bear with me for a second. I have a little one at home. She's cute, she's 18 months old, she's learning to drive. And my threat model is everything's dangerous. Everything. She walks around the house like, oh my god, everything. Like, take everything away from her past. She tries to climb downstairs and like everybody's gonna die. It's terrible. All I want to do is to buy a bunch of bubble wrap and just wrap her and just have her run around the house like making sure like. And apparently you can buy some of these on Amazon. Anyways, there's something that Grace Hopper, who's one of my personal heroes, said once is she was working for the military. She built one of the first compiler. Ships are safe in harbor, but that's not what ships are for. We're not here to prevent organizations from falling and hurting themselves. We're here to help them not do that too often. Yes?
There's one time when this is not true, and it's a hurricane, and you're in Florida.
This is true. But actually, if you have a hurricane come to Florida, just take the boat and get the fuck out of here. What a lot of security teams end up doing is that they patronize. That's something you see a lot of people do. They think it is their job to prevent the devs and the ops in the organization from doing stupid things. I can do that with my kid. I can't do that with my coworkers. In fact, a lot of the product managers and business owners and engineers, they know how to appreciate risks much better than I do. I know how to threat model security risks, but that doesn't mean I know how much risk the organization should be taking on an initiative. I don't have that visibility. I don't know if it's okay to lose $3 million on something, on a crapshoot. That's not my code, and it is their code. So I don't paternalize when I do security reviews. What I do is I inform. We run something we call the rapid risk assessment. It's a 30-minute to 1-hour conversation with product owners, with developers, with engineers, before, at the beginning, during their design phase, where we essentially collect, we ask them everything that they're doing, and then we run through a threat model, and we help them think through the implications of their project blowing up. What if the database ends up unclear? What if a bad actor modifies the entries in the database, etc.? And this helps us essentially have them think about issues and risks and ways their application could fail, and helps them think through controls and techniques that they could implement to make things less risky. And then they can decide for themselves whether it's worth it or not. I'm at time, so I'll pass over this one quickly, and honestly, I only have one thing to say here, is that if you have to make decisions, the job of a security team isn't to fix a bug, it's to fix classes of vulnerabilities in your organizations. It's to be strategic about what battles you pick, so you can invest. If you invest somewhere, make sure it's going to eradicate an entire class of issues and not just fix that one firewall. The conclusion I'd like to leave you with today is, if you want to go beyond the security team, if you want to retire tomorrow and just go do something else in this silliness of asking for more budget year after year, get closer to your organizations, get closer to your operations team, your developers, your product owners, go work with them on issues, and eventually, at some point, they won't need you anymore. Thank you very much.